Okay, I just thought I'd do one example of using the unit circle in order to evaluate different angles, cosines, sines, etc. Now with this trigonometry, we didn't have the third lecture, so haven't had as much time to go through some examples, but I think our straightforward understanding using our sqrt, so that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. So if I have some kind of situation like this, then I can work out this side here by saying that tan of 20 degrees, call this x, must be equal to 3 on x, and then solving for x. Or I could work out this side here, y, by saying that sine, since I'm now dealing with these two, sine of 20 degrees must be equal to 3 on y, etc. So I think those things are okay. But this is a little bit more, I think this is a little bit more complex anyway. So I've got cosine of theta equals the square root of 29 on 7. And these are pretty horrible numbers. Now remember, cosine of theta always gives a value between 0 and 1, or actually between -1 and 1. So if this is not between -1 and 1, then there's something that's going wrong. But we know that the square root of 29, it must be a little bit above 5, because the square root of 25 is 5, and definitely below 6, because the square root of 36 is 6. So it's somewhere between 5, so this is, about approximately 5 and a bit sevenths. Now, relating it to sine of theta, not actually theta itself, I can still do all this without a calculator. I start by just imagining the triangle, and with cosine of theta I know it's adjacent over hypotenuse, so if this is theta, then I can call my hypotenuse here and my root 29 here. To work out my sine of theta here, I then just can use Pythagoras' theorem. So remember, Pythagoras' theorem is a squared plus b squared equals c squared. In this case, that gives me root 29 squared plus 7, plus, what are we going to call this? Let's call it x, plus x squared equals 7 squared. Or 29 plus x squared equals 49. Subtract 29 from both sides, I get x squared equals 20. So x must be equal to the square root of 20. I don't need to worry about plus or minus in this case because it's a length. So I don't need to have the minus there. So let's chuck that into there. So I can now replace this, and I've got this is equal to root on 20. So I'll get rid of all this. Now, in this case, using the triangle ratios, I can say that this is the situation that I have. But another thing that we need to remember, and so sorry, I can work out sine theta must therefore be equal to root 20 on 7. So I don't even need to worry about the thetas or whatnot. And I could make this a little bit neater, since 20 is 4 times 5 and the square root of 4 is 2. This is 2, 5, and 7. However, if we think about the unit circle, remember if cos of theta equals 29 on 7, so that's root 29 on 7 is some moment here, theta could actually be here. Okay, that would be if it was there. So that gives a cosine of this side length here. But it could also be down here. So, if I did the workings out and I found out that theta here was, maybe about 70 degrees or something like that, then actually theta could be 70 degrees, but it could also be negative 70 degrees because of how cosine works. And that means if all I know is that cosine of theta equals root 29 on 7, and I don't know what the context is, actually sine of theta of the angle, because theta could be here or theta could be here, So sine of the angle could be either here, which we know from our rules here that this is root 20 on 7, but equivalently it could be over here at negative of that. So we need to be really careful. Now a lot of the questions, they'll say something like cosine of theta is here, theta in first quadrant. Or maybe we might say something like sine of theta equals 0.5 theta in second quadrant, which would mean that we're dealing with, this angle here, etc. So again, as I said in the lecture, I think it's important to sort of think about the unit circle, think about all of the symmetries, etc. that are going on before we do a number of these practice questions, etc. Alright, I hope you have a good weekend. Bye.